We have seen how to create classes with member variables and provide a constructor to initialize those variables. The next thing we want to do is to figure out how to add functionality to classes. And as you can see from the old code, we still have some functions to describe a person given a name, age, and a height. So now that we have a person class, it would be nice if we could move these functions inside the class itself. And this makes sense because these functions provide functionality that is relevant to the person class. So let's go ahead, and here I can cut these functions and then I can paste them inside the class itself. And I'm just going to fix the indentation quickly, just like this. And we're ready to continue. Now, one thing that I want to point out is that these functions all take some input parameters. However, these input parameters are no longer necessary because the functions themselves now have access to the member variables inside the person class. So let me remove these parameters, just like this. And this one as well. And what I can do now is to go back to the main method, and over here I can print person.describe, for example, and I can run the code, and I can see that the correct string is printed to console. Before I continue, I want to choose only one of the two methods over here, since they do the same thing. So I'm going to remove the first one, and I'm just going to keep the second one and rename it as describe, just like this. So in summary, we have found a way to use functions inside a class. And by doing so, we have discovered that functions have access to all the member variables that are declared inside the class. And by the way, when a function is defined inside a class, it is also called a method. So just remember that every time I use the word method, I mean a function that is inside a class. So let's continue on the next video. Now that we have covered some basics about working with classes, we are ready to introduce a new concept called inheritance. And inheritance is just one of many ways of extending the functionality of existing classes. And inheritance is a relationship between two classes. So to explain this, let me open up a diagram. So when we talk about inheritance, we often refer to a base class and to a subclass. And we say that the subclass extends the base class. So in this example, we have the person class that we have already defined, and we introduce a new employee class which extends person. So to see how this works in practice, let's get back to Dartpad and add our employee class. So over here we can type in class employee extends person and then open brackets, and we want the employee class to have two member variables defined like this: final string tax code and final int salary, like this. And as we have seen before, we need to add a constructor to the employee class. And this is required if we declare any member variables to be final. In fact, the compiler is telling us that the two variables must be initialized. So let's add a constructor, and here we can type in employee and then open brackets and then open curly braces. And here we can type in this dot tax code and this dot salary. And that makes the compiler happy. With this change, we can get back to our main function, and here we can create a new employee. So I could say final employee equals employee with tax code. And here, for example, I could pass in A, B, 1, 2, and then salary is 50,000, like this. Okay, so let me just clean up the code a little bit. And now, because the employee class extends from person, then it means that this employee object can access all the member variables and the methods of the person class. So to prove that, here we could type in employee.sayName, which is a method inside the person class. And we could try to run the code, and what we get on the console is hello, I'm null. And the reason for this is that even though employee extends person, we don't actually pass any variables to the constructor of the person class when we create a new employee. So let's fix that in the next video. In the last video, we created a new employee class. However, when we call the employee constructor, all the member variables of the person class are initialized to null. And that's because we don't pass any values to the constructor of the person class. So let's fix this. If we head to the constructor of the employee class, we can now add 3 more parameters. So in here, I can type string space name and then int age and double height, like this. And then I need a way to pass this to the constructor of the base class. So to do this, I'm going to go on a new line here, and then I can type a colon space super, and then within brackets, I'm going to pass the parameters. So name, colon, name, comma, age, colon, age, comma, height, colon, height, like this. So what this code does is to take 3 extra parameters and pass them to the constructor of the super class, which in our case is the person class. So to verify that this code works, here we could take the 3 parameters that we are passing to the person constructor, and we could copy and then paste them into the employee constructor, like this. So I'm just going to clean up the code a little bit, and then at this stage I could run the code once again, and this time I can see hello, I'm Andrea on the console, and this confirms that the Andrea parameter is passed from the employee class all the way to the person constructor, and when we call the same name method, then it's printed correctly. So this is how we use the super constructor when extending classes. So let's continue on the next video. We have now learned how to work with subclasses in Dart, and we have seen that subclasses have access to their own members and methods, as well as those of their own superclasses. Now, there is one thing that I forgot to mention, and that is that all classes in Dart descend from the same class, which is called the object class. And to show you this visually, I can open up a diagram. As we can see here, the person class extends the object class, and this happens automatically, even if we don't write this explicitly in our code. So what does the object class do? To answer that question, we can quickly look up the documentation in the Dart core library, which we can find at this address. So the documentation says that the object class is the base class for all Dart objects, and because object is the root of the Dart class hierarchy, every other Dart class is a subclass of object. And then, when you define a class, you should override toString to return a string describing an instance of that class. So what does this mean? If we scroll down the file, we can find a list of constructors, properties, methods, and operators for the object class. And by the way, I previously talked about member variables when creating classes. And for clarity, member variables are also called properties. Okay, so for now we are interested in the toString method. And the documentation for this says that toString returns a string representation of this object. So let's get back to Dartpod, and we can continue on the next video. We have now learned about the object class and the toString method. And the next thing I want to do is to use the toString method to show you how it works. So over here we can add a new line and type print, and then within brackets employee.toString, like this. And just as a reminder, we can do this because employee is a subclass of person, which in turn is a subclass of object. And instances of type employee have access to all the methods and properties of all their superclasses. So if we run this code, we get now a line that says instance of employee. And this is what is returned by the toString method in the object class. So this is good because it helps us to find out the class name of the instance being used. However, we would like to make the toString method a bit more useful and specific for the classes that we have created. So to do that, we could implement the toString method in the person class. And another way of saying this is that we're going to override the toString method of the object class. So let's do this. In the person class, here I'm going to type in string and then toString with brackets and then arrow operator, and then within single quotes I can type in name, colon, dollar, name with string interpolation, and then comma, age, colon, dollar, age, and then height, colon, dollar, height, like this with a semicolon in the end. So if we run the code again at this stage, we can see that on the console log we get name Andrea, age 34 and height 184. And this is the string that is returned by the toString method in the person class and not the one from the object class. And this is because we have overridden the toString method. In general, the way that method overriding works is like this. When we call a method on an instance of a specific class, such as the employee in this case, the Dart runtime will check if the current class implements that method. In this case, the toString method is not implemented by the employee class. So what Dart does is to look up at the superclass, which is person. And in this case, it finds the toString method that we have just implemented. And if the person class didn't have an implementation for toString, then Dart would go another level up and use the toString method in the object class. So this is how method overriding works. By the way, when we override methods from superclasses, we should remember to add an @override annotation above the method that we are overriding, like this. Okay, so if we want, we can take things further, and we can also define the toString method in the employee class. So over here, I can add a new line and type @override and then string toString with parentheses, then arrow operator, and within double quotes I can type dollar, open and close braces, and inside here super.toString, and then comma, tax code, colon, dollar tax code, and then the same for the salary, like this, and a semicolon in the end. So we can run the code again, and on the console log we can see that the toString method from the employee class is now used. And the way this works is that here we get the result of calling toString on the superclass, which is person, and then we use string interpolation and add the tax code and salary as well. In summary, in this video we have learned how to use method overrides. And if some of this content is not entirely clear to you, then don't worry, because we will have time to look at more examples going forward. For now, the key takeaway is that if we want, we can implement the toString method in our classes, and this is helpful when debugging our code and printing things to console. As a final observation, I want to point out that here I could just say print employee and omit the .toString syntax, and this will have the same effect. And the reason for this is that the toString method is called automatically when we pass an object to a method that takes an object as an input, such as the print method. Okay, so we have now completed our overview of inheritance in Dart. In the next videos, we will introduce some new features of the Dart language, and to do that, we will start with a fresh new pod. So over here, I'm tapping on new pod, and I'm going to discard the current one. And then we have a fresh new pod. So let's continue on the next video. Now that we have become familiar with classes in Dart, we are ready to introduce a new special type of class, which is called an abstract class. So what is an abstract class? An abstract class is a class that defines some methods and properties without specifying how they are implemented. So let's take a look with an example. I'm going to clean this code first, and then I can type in abstract class shape, and then curly braces. And then inside here, I'm going to define a method which returns a value of type double. The method is called area. And then I'm going to have open and close brackets, and then a semicolon, just like this. Notice how I'm not providing a body for the area method in this class, and instead I only declare the method itself. So one important thing to know is that abstract classes can't be instantiated. So what does this mean? In the main method over here, I could type in final shape equals shape, like this. But as you can see, the compiler shows us an error telling us that we can't create an object of type shape. And this is because shape is an abstract class. So what are abstract classes useful for? Well, they can help us to define an interface that is common to multiple classes. To show you what I mean, I'm going to create a new class that implements the shape abstract class. So here I can type in class square implements shape, like this. And as we can see, the compiler tells us that we need to implement the area method from the shape class. So let's do that. In here we can type in double area, open and close brackets, and then I'm going to use the arrow operator, and then for now just return 0.0, just like this. And this is just so that we can make the compiler happy. Of course, this is not a good implementation of the area of a square. So what we are going to do now is to add a new variable, which we are going to call final double side, just like that. And in order to initialize that variable, we are also going to add a constructor. So here I can type in square, and then open and close brackets, and then open and close curly brackets. And here I can say this.side, just like this. And now that we have a side property, we can use it to return the correct value for the area. So here we can type in side times side, like this. And now that our square class is ready, we can create a square. So we're going to delete this line over here, and then we're going to type in final square equals square with side, which is 10.0, for example. And then we can print square.area, like this. And now we could run this code, and we can see that on the console log we get the area, which is 100. So let's continue on the next video. In the last video we have created a shape abstract class, and we have added a square class as a concrete implementation of shape. Now, if we wanted, we could create additional classes to implement shape. So for example, here we could type in class circle implements shape, like this. And just in the same way that we have implemented the square class, we could define a final double radius variable and a constructor as well. So we could type circle, and then within brackets this.radius, like this. And then we can implement the area method. So here I could type in double area, open and close bracket, and then arrow operator, and then I can type radius times radius times pi, like this. And the only problem that we have now is that pi is not defined in this file. So we can solve that by importing it from the Dart math library. So at the top of the file, I can type in import and then single quote, and inside here, Dart colon math, and then semicolon in the end. So for now, don't worry too much about this syntax, and all you need to know is that in Dart you can import functionality from other libraries with the import keyword. And because the pi variable is defined in the math library, our code now compiles. Okay, so now that we have defined the circle class, we can try to use it. So in our main function, we can create a final circle equals circle with a radius of 5, for example, and then we can print circle.area. And then we can try to run this code, And as we can see, the area is now printed. So let's take a look at the class hierarchy that we have just created with a diagram. So over here we have the shape abstract class that we have created, and then we have two implementations of the shape class. And as we can see, both the square and the circle class implement the area method. Okay, so let's continue on the next video. Now that we have created both a square and a circle class, I want to point out one thing. And that is that here we are creating instances of objects of type square and circle by using the final keyword. And because of this, the Dart compiler infers the type of the object being created. However, I want to show you something interesting. So over here, I'm going to create a new function, which is going to be void print area. And this will take one parameter of type shape, and it's going to be called shape. And all this function does is to print the shape.area, just like this. So just to be clear, this function takes one input argument of type shape and prints the area of that shape. Now, what we can do with this is to go back to our main function, and here we can replace this line with print area, and with passing square as an input. And similarly, here we can type in print area with circle, just like this. And if we want, we can run this code and we can see that the output is the same. So what is happening here is that we have created two objects of type square and circle. However, it is perfectly valid to pass these objects to a function that takes shape as an argument. And the reason this is valid is that both square and circle implement shape. In other words, by defining an abstract class, we are creating an interface and we can write code that uses that interface without knowing anything about the underlying implementation. And this is a powerful concept that can help us writing better code. Okay, so let's continue on the next video. Now that we have completed our overview of abstract classes, I want to introduce a new concept known as a computed property. Computed properties are a feature of the Dart language that can be used to define properties whose value is computed rather than stored. So in this example, we can see that the square class has a property called side, and side is a stored property. What we are going to do now is to introduce a computed property. And to do that, I'm going to change the implementation of the shape abstract class. So over here, I'm going to change this declaration by removing the brackets, and then I'm going to add a new keyword in here called get, just like this. So what I've done here is converted the area method into a computed property. And after making this change, I get some compiler errors because the square and circle classes still use the old implementation of the area method. So let's fix this. And here I can change this by converting the area method to a getter property like this. And I can do the same for the area method in the circle class as well. And finally, I need to change the code that prints the area of the shape. So here I can simply say print shape.area like this. And I should be able to run the code, and I can see that the console still prints the same thing. In summary, I have converted the area method into a computed property by removing the brackets and using the special get keyword. And I think this is something that improves the readability of my code, because when I call shape.area, I no longer need a pair of brackets here. And just so you know, when we talk about computed properties in Dart, we can have property getters like the one we just added, but we can also have property setters. However, I'm not covering property setters here, and you can look them up in the Dart documentation if you're interested. So we have talked about classes and their methods and properties, and we have also covered inheritance and abstract classes. For now, these are all the basics that we will need to be able to work with classes in Flutter. And there is much more that could be said about classes in Dart. So if you're interested in learning more, I recommend checking out the official Dart documentation about classes, which you can find here. Okay, so let's continue on the next video. In the last few videos, we have learned how to use classes in Dart, and there is one more language feature that is often used with classes in Dart, and that feature is called a mixin. So in this example, I'm going to show you what a mixin is and how to use it. So over here, I have a modified version of the person class that we created before, and as you can see, I've added an extra argument called weight. So in this example, I want to show you how to calculate the body mass index for a person, which is also known as the BMI. And then we will see how we can use a mixin in this context. So first of all, I want to add a method to calculate the BMI of a person. So this is going to be a double, and it's going to be called calculate BMI, like this. And in here, I can return weight divided by height times height. And this is the formula to calculate the BMI. Now, this works, and if I wanted, here I could print the person.calculate BMI like this. And if I run this code, we can see that the BMI is printed on the console. Okay, so now that we have done this, we can introduce a mixin. And you can think of a mixin as a way to extend the functionality of existing classes. So let's see how this works in practice. Over here, I'm going to create a new mixin BMI, and then I'm going to copy the code from this method and paste it into the mixin like this. And because I moved this method inside the mixin, then I get some errors because the width and height are not defined. So in order to address this, I'm going to pass them in as arguments. So I can type double weight and double height like this. And now that I've done this, I'm going to add BMI as a mixin to the person class. And the way to do this is by typing width and the name of the mixin, which in this case is BMI, like this. By the way, once I do this, I see that I get a new error. And this is because both the person class and the BMI mixin define a method called calculate BMI. So what I'm going to do now is to replace this method, and instead here I'm going to add a computed variable. So here I can type double get BMI and then arrow operator, and then calculate BMI with weight and height, like this. And the reason I can do this is that the calculate BMI method is defined inside the mixin, and I have added this mixin to the person class over here. So finally, I can update my print statement to just say print person.bmi like this. And if I run this code, then I can see that it prints the same value as it did before. Okay, so this is how we can use mixins in practice. So let me go through this once again. First of all, we create a mixin by using the mixin keyword. And inside the mixin, we can add instance variables and methods like we would do for a regular class. Then we can add a mixin to a class by using the with keyword like this. And this means that we have access to all the variables and methods that we have defined in the mixin inside our class. And in this case, we have decided to use this to create a computed property called BMI, which returns the result of the calculate BMI method that we have defined inside the BMI mixin. So there are cases where mixins are useful, especially when we want to extract some functionality from our classes so that it can be reused. And we will see some examples of how to use mixins in this course. By the way, there is more about mixins than I have covered in this video. So if you want to learn more about mixins, then you can head over to this section of the Dart language tour. Okay, so let's continue on the next video.